Hello guys, this is my third videos about the electric circuits or electric currents, okay? So I hope that before you continue this video, you have to make sure that you have already understood my last two videos. This is the learning objective that we are going to discuss in this video. You can read here, and if you have some that you don't understand, you can take a note and ask me. Before we continue, I'm going to review some that we have already learned or we have already understood in the last video, part 2. It's about the currents and the voltage in the circuits and in the series circuit and the parallel circuit. Okay, remember guys, this is the series circuits. Okay, and this is the parallel circuit. So in the series circuit, the current is always the same. Okay, you can see from these equations. In parallel circuit, the current is the additions of the current in each branch. So that's why I1 plus I2 plus I3. Okay, but if the voltage in the series, the voltage or the potential difference is added in each electrical component. But in the parallel, the voltage is equal. So from here, we can get the resistance. Okay, so we have learned that by using this formula, we can derive the formula of the resistance. So Vt equal to V1 plus V2 plus V3, right? Then we have learned it in the last topic that the V equal to I times R, Ohm's law. So right, then you can replace the potential difference into this formula. So I times R, okay, R total, yeah, or some books said that this is the, so RT is R total or equivalent resistance, okay, or the total resistance or the effective resistance. So it's the same, don't be confused with this term. Okay, so equal to I1 times R1 plus I2 times R2 plus I3 times R3, right? Okay, and we have learned it if in series, the current is equal, right? So we can cancel the current. The current is equal. So this all is equal. Then we get the equation. The effective resistance or the equivalent resistance equal to R1 plus R2 plus R3. Okay, clear? Okay, so we can conclude that if all resistance is identical, then the R total will be the N. N is the number of the resistors times by the resistance for each resistors. How about the parallel one? Yeah, if the parallel one, we use these equations. Okay, IT equal to I1 plus I2 plus I3, right? Then how to find the I from these equations? So the I equal to V over R, right? So V over R equal to V1 over R1 plus V2 over R2 plus V3 over R3. So this is V total, yeah, V total, the total potential difference in the circuits. This is the R total or R effective or equivalent resistance. Then you can see from this equation, the voltage is equal. So we can cancel this all because the same, right? Or you can write down like this. So Vt per RT equal to, V, right, times by 1 per R1 plus 1 per R2 plus 1 per R3. Then you can cancel these two. Then you get the equations. 1 per R total equal to 1 per R1 plus 1 per R2 plus 1 per R3. Okay? If all of them are identical, okay, so the RT, so 1 per RT will be N per R, right? If all is identical. If RT, then switch, become R per N. Don't forget to switch, guys. I have already seen a lot of students forget with this one, then cannot switch and forget to switch. Then of course your calculation will be wrong. So don't forget, yeah, you have to change the RT. Yeah, 1 per RT become RT, okay, by turning upside down the R and N. N and R, I mean, become R per N. This is the example, okay, the one that we are going to do right now. So the question of this is find all the faults or all the potential difference and the current or amps in this series circuit. So what should you do? For the first time is you have to find the total resistance or the effective resistance. We know that this all is series. There is no branch. So if series, then we can assume that the effective resistance or the RT equal to R1 plus R2 plus R3, right? So the R1 is 2 ohm plus 4 ohm plus 6 ohm. So the total is 12 ohm, right? Okay. Then after you have got the RT, then you have to find the total current, so the I. So we have learned from the Ohm's law, the I equal to V over R. Okay, the question gives you the 12 volt electric source. So 12 divided by, yeah, of course we find the current, right? So we use the total resistance. Then it has 1 amperes flow in this circuit. Remember, the flowing of the current always from positive to negative, so the direction must be like this, right? So there is 1 amperes flow in this circuit. So this one also 1 ampere because there's no branch, so all resistor will get 1 ampere of current. Okay, so we can conclude that I same with, so this is I1, the I in the first resistor, I2, and this is I3. Okay, I equal to I1 equal to I2 equal to I3 equal to 1 ampere. Okay, now we are going to discuss the potential difference or the fault in each resistor. Okay, how to measure the voltage in each resistor? You have to connect the voltmeter in parallel, right? So like this, right? So this is V3. So this one should be R3, yeah? Yeah. Okay, so in here is V2. Okay, and this one is V1. Okay, how to count the V1? V1 equal to I1 times R1, right? So the I1 is already given here, 1 ampere times by 2 ohm, then 2 volt. Okay, so V2 is the same, 1 ampere times 4 ohm, then we get 4 volt. V3 is 1 ampere times 6 ohm, we get 6 volt, right? And we can check this all is 12 volt, right? So same with V total, and your answer is correct. Okay, any question for this? If you have a question, you can text me, you can chat, or you can ask in general in Teams. How about if the questions like this? So be careful, guys, this is different with the first one because there is a internal resistance in here. So 1 ohm is the internal resistance. And 12 volt is not the terminal voltage, but this is the EMF. Yeah, EMF. Okay, if like this, it will be different. Okay, so what should we do? The steps still the same. You are finding the R total. R total is 4 ohm, right? Plus 5 ohm, plus 3 ohm. Then the total is 12 ohm, right? Okay, and after that, how to find the current? Remember, the EMF in our last video we have already discussed, right? I times the R total plus internal resistance, right? Then we have to find the current. I equal to EMF over R total plus internal resistance. So 12 divided by the R total is 12 plus this one internal resistance 1. Then we get 12 per 13 ampere. Okay, this is the currents that flow in this circuit. Okay, now how to find the terminal voltage? TV, yeah. Terminal voltage is the voltage that out. Okay, the voltage in this circuit. So the terminal voltage is V equal to I times R equal to 12 over 13 times the RT is 12. So 144 over 13 volt. So if you put your voltmeter in here, the one that the voltage that measured by the voltmeter is the terminal voltage. Okay, why not 12 volt that go up? Because the internal resistance will decrease the voltage. Okay, well, because of what? Because of heat maybe. Okay. Now how to count the V1? V1 still the same. I times R equal to 144 over 13 times by 4, right? Yeah, so the answer is 16, 17, 5 over 13, 4, right? V2 is I times R also, so 144. Okay, I'm sorry, this is wrong, yeah? I have to erase. We cannot use the V, yeah? You have to use the I. So this one should be 12. Little bit nervous, guys. I hope that you understand, okay? So 12, sorry, this is 12 per 13 times 4, so 48 per 13. Okay, this one also 12 per 13. Why we use the same I? Because this is series, so the current is stay the same. R2 is 5. So 60 over 13 volt. Then the V3 is 12 over 13 times 3. 36 over 13. Then you can check when you add this all, is this the same with the terminal voltage or not? Okay, 8 plus 6 is 14. 1, 5 is 11, 14. Okay, check, yeah? Done. Okay, if you have a question, please ask me. Guys, this is a parallel circuit, yeah? So how can we know? You can see that this is the positive and negative. Currents flow from positive to negative. Then it starts to divide the currents here. Yeah, divide it into 3. So there is I1, I2, and I3. Okay, yeah? So how to count the current in each resistor? Okay, of course, the first things that you do is you have to count the R total, or 1 per R parallel equal to 1 per 4 plus 1 per 6 plus 1 over 2, and you can make them the denominators. I make it into 12, right? 12, and this is 3 plus 2 plus 6, okay, 4, yeah, 12 divided by 4, 3, 4, 3 divided by 2, 2 divided by 8, 6, 2 divided, okay, so the answer is 5, 11 per 12. But don't forget, guys, warning in here, this is not the answer yet. You have to find the RP. RP you have to turn upside down, become 12 per 11 ohm. This is the most common mistake. I always find students forget to turn it upside down. So don't forget, I've taught you from now. Okay, then after you get the RP, then you can find the I, the total current that flow in this circuit. The I is phi per RP, right? So the phi is 24, okay, per 12 per 11. So become 24 per 12 times 11. Yeah. Then we get how many? This is 2. So 22 amps. After you get the total current in this circuit, then you can find the I1, I2, and I3. Okay? Because this is the parallel circuit, though we can assume that the phi1, yeah, is equal to phi2 equal to phi3 equal to the phi total equal to 24 volt. Then if we want to find the I1, then we can use phi per R. R1, yeah, phi1 and R1. So phi1 is 24 divided by 4. Then we get 6 amps. Okay. The I2 is 24 over 6, we get 3 amp. I3 is 24 over 6 equal to 4 amps. Then you can check, if you add this all, then it gets 6 plus 9, and then plus this is, okay, sorry, this one should be, the I3 should be 24 divided by 2, so 12. So 15. Okay, this one should be 4, okay? Yeah, so you get 22 amps equal with the I total in here. The same. Okay, this is for controlling how to check your answer is correct or not. Okay, actually you don't need to find the I total if you want to find the I in each branch, because the voltage is already the same in here, right? Or you can use another way, the one that I have already discussed in the last slide. Use the ratio one. Yeah, ratio method. So I1 to I2 to I3 equal to, yeah, phi per R1 to phi per R2 to phi per R3. They are having the same phi, right? So we can cancel. Then we get 1 over 4 to 1 over 6 to 1 over 2. Then you can times this all by 12. Then we get the ratio is, yeah, 3 to 2 to 6. Yeah. So how to find the I1? Continue here, yeah. I1 is, the I1 is 3, right? And we know that the R total is the total from this one. Okay, so 3 over 3 plus 2 plus 6 times 22. Then we get 3 over 11 times 22. Then you get the answer is 6m. Then the same, right? Okay. Then you can use this way to find the I2. Okay. And I3. So I2 will be 2 over 11 times 22. And the answer is 4 amps. Okay. I3 would be 6 per 11 times by 22. Then you get 12 amps. And you see this all is the same. For this question, guys, you cannot use for a 14 volt as the voltage in each resistors. Why? Because 14 is not the terminal voltage. Okay, 14 is the EMF. Okay, be careful with this. If you use 14 for this all, this is 14, this is 14, and 14, your answer will be wrong. Okay, because I give the internal resistance in here. So be careful with this. Yeah, if there is a resistance beside the voltage, it means that there is an internal resistance. Okay, so 14 is the EMF. Okay, so to count to count the current, you have to use the EMF. Okay, then what should you do for the first time? You have to count the RT first. Okay, there's no other way. You have to count the RT. Okay, you have to get the I total. So how to count the RT? Still the same. 1 per RT equal to 1 per 1 plus 1 per 2 plus 1 per 3. Yeah, make it into 6. Okay, I think you have learned this in the primary, right? Then this one is 1 per 1 is 6 per 6 plus 3 plus 2. Okay. Then the answer is 11 per 6. But don't forget, guys, this is not the answer yet. You have to find the RT. It should be 6 per 11 ohm. Okay. 6 per 11 ohm. After that, find the current. So current is EMF per R total plus internal resistance, right? So 14 over 6 per 11 plus 1. Then 14 over, yeah, this one become 11 per 11. So become 17 per 11 or 14 times 11 per 17. So the answer is 1414. So 154 per 17 amps. Okay, then you can count the terminal voltage. The voltage at odd, yeah, terminal voltage is I times R total. Okay, so 154 divided by 17 times by 6 per 11, right? Okay, then this one and this one become 14. Okay, so the answer is 24 to 84 over 17 4. And after that, you can find the I1. So for the I1, you use the terminal voltage. Okay, you cannot use 14 anymore. You have to use the terminal voltage. So terminal voltage V per R1. So 84 per 17. Yeah, divide, or I can say times by 1 over 1. So the I1 is 84 per 17 amps. I2 is 84 per 17 times 1 per 2, then become 42 per 17A I3 is 84 per 17 times 1 per 3. Yeah, 24, so 8 2, 28 per 17a. Okay, you can check, if you add this all, then the answer should be equal to the I total. Let's check. So 4, 6, so 14, 1, 9, 13, 15. Okay, check, already same, If you add it all, then the answer is this one. Okay, any question, guys? Hope that you understand, Okay, this is the more challenging questions, but not really hard actually. So what should you do if you get these questions and you have to find the current and the potential difference in each resistor? Okay, so how to count it? So the first step you have to do is always start to find the effective or the equivalent resistors. And this question didn't give any internal resistors. So the R is 0, there's no internal resistance. So that's why we can assume that the voltage or the terminal voltage is 3 volt. Okay, so we start with finding the internal, the effective resistor or the total resistor. As you can see here, how the current flow? Current flow from positive to negative, so flow here, right? So in R1 only have I. Okay, but when it goes to this junction, then the current is split. Okay, this has become I1, this is I2, and this is I3. Okay, then after that, in this junction, the I2 and I3 is combined again, become I1 again, or I total. Okay, so the first thing that you have to do is you have to change this circuit, okay, become more simple. So this is R1, this is the R parallel from the combination of these two resistors, resistors 2 and resistors 3. How to count the R parallel? So R parallel, you can use this formula 1 per R parallel, or there is another formula, RP equal to R1, R2 times R3 per R2 plus R3. You only can use this formula if the resistor only 2. If more than 2, you cannot use this, okay? Where this come from? I think you can derive from this formula. 1 over R equal to 1 over R1 plus 1 over R2, right? Then you do the cross multiplications. Okay? Yeah, so the RP is the multiplications divided by the additions. Okay, but luckily these two are equal, right? Then you can say the RP is 20 per N, 20 per 2, 10 ohm. Okay, then how much the R total? The R total will be, this is series, right? The combination of these two. Got R series, right? So R total is in series, so 5 ohm plus 10 ohm, the answer is 15 ohm. This is the R total. Now how to find the I? V per R total, so 3 volt divided by 15, so 1 per 5 amps. Okay, clear, guys? If you have a question, you can screenshot these and send via message or in the discussion in the general. Okay, then we have learned that the I1 is equal to I total, right? So this one is 1 over 5 amps, right? Then how to find the I2 and I3? Okay, to find it, you can use the ratio, or you find the voltage in here. You find the V2 and find the V3. V2 and V3 must be equal. Yeah, so V2 equal to V3. Why? Because parallel, right? But remember, this is not the same with 3-fold, because 3-fold is the combinations of the voltage in the circuit. Because R1 is R1 is series with the parallel resistors. Or we can say that V1 plus V parallel, okay, equal to 3-fold. Okay, yeah, remember this. Now how to count the V parallel? So the V parallel is the I in parallel. So in here, yeah, the I in here, times by the R parallel. So the I parallel is, of course, same with the total current flow, right? 1/5 times by the 10. So 2-4. Yeah. So the V1 is I times R1. So the I is 1/5 times by the R1. The R1 is 5. So 1/4, right? You see? Same with my checking. 3/4, right? Okay. Now the next one is, if finding the V1 and V2, I think already same with this one. So V1 equal to V2, then equal to V parallel. So V2 equal to V3, equal to V parallel, because they are in parallel. Okay. Yeah. Then how to count the I2? V parallel, or V2 divided by R2. So 20 divided by, sorry, the V parallel should be 2 divided by 20. So 1/10 amps. The I3 is 2 over, yeah, the I3 is 20 also. 1/10 amps. And you can check, if you add these two together, it's become I total, right? Yeah, become 1/5. Yeah, if you add it, it's become 1/5 total. So your answer is correct. Any question, guys? If you have a question, you are free to ask. This is the summary from the step that I have already explained. So, of course, you have to figure out the current that flow in the circuits. Which one is I1, which one is I2, which one is I3, right? And after that, you find the parallel resistors, okay, into the equivalent single series resistor. So the one that I said, simplifying this one, okay, become this. And after that, you have to find the total resistance. So this all, find the total resistance. Okay, and then after that, find the currents. Okay, yeah, 1/5 amps. After that, find the voltage in R1. Yeah, V1. After that, find the Vp equal to V2 equal to V3, right? Yeah, and remember, the sum of the voltage drops equal to the voltage of battery. So V1 plus Vp is equal to 3/4. Okay, that's all. Yeah, you can try this simple step every time you find a question like this. Okay, so how to do these questions? So the first thing that you have to do is simplify these circuits, okay? How to simplify it, and you see how the currents flow. The currents flow from positive to negative, so this should be I. Okay, in this junction, the current is start to divide it, become IA and IB, right? And after that, in these junctions, it's become I again. Okay, and start in these junctions, the I is divided again, become IC, okay, ID, and IE. And in these junctions, it's become I again, okay, or IF. Same with I. Okay, then we will do step by step, simplify this circuit first. Okay, so for the first one, you can do like this. Okay, this is the R parallel between A and B. Okay, and after that, this one, you can simplify also, R parallel 1, so become R parallel 3 between C, D, and E. So become like this. Then after that, the last one is, yeah, RF. Then this all is series, right? Series. So later the R total is in series. Let's do step by step. Okay. So the RP1 is equal to 15 times 5 divided by 15 plus 5. You can use another way if you want. It's okay, no problem. So 75 per 20. So we get divided by 4, divided by 5. So 15 over 4. Yeah. Ohm. Okay. And then find this one, yeah. Now find this one. R parallel 2 is, yeah, if this one, I think you cannot use this one anymore, okay? You have to use 1 per R parallel equal to 1 over 2 plus 1 over 6 plus 1 over 3, sorry, 2, 2, 3, and 6. So make it same, 6, and then 3 plus 1 plus 2 equal to 6 per 6. So the R parallel 2 is 1 ohm. Okay, now how to find the R total? Because all is in series, right? So RP1 plus RP2 plus RF. So 15 per 4 plus 1 plus 1 per 4 equal to 16 per 4, 5 ohm. Now finding the I, guys, the current. So the current is volts V per R total. Then you get 20 over 5. So the current is 4 amps. Okay, this is the total current. Okay, now how to find the voltage in each resistor? Okay, to find the voltage in each resistor, I can split. Maybe I can use this one. Okay, so in here, VP1 and then VP2, and this is VF. If you see this diagram, then you will get the result is V equal to VP1 plus VP2 plus VF equal to 24. Okay, how to count the VP1? So the VP1 is equal to I, the I total, right? This is I total, I times RP1. Okay, so the I is 4 times by the RP1. RP1 is 15 per 4. Okay, so equal to 15.4. Okay, phi P2 is equal to same 4 times 1 equal to 4. Okay, phi F is equal to 4. Yeah, the I is 4. Yeah, 4 ohms flow here. Yeah, 4 ohms flow here. Okay, 4 ohm times by 1 per 4 amps. Then you get 1/4. And make sure to check the total must be 20. Yeah, 15 plus 4 plus 1. Done, 20. Okay, then you get the phi P1, phi P2, and phi F. So the phi A, okay, phi at A will be the same with phi P1, right? Because these two are the same. This phi A will be the same with phi B. Okay, so the phi A is 15/4. This one also 15/4. Okay, how about the C? The phi C and phi D and phi E will be the same, right? Then all of them is phi P2 or 4/4. Yeah, 4/4. Okay, 4, 4, and 4. Okay, understand, guys? And after this you can calculate the I. Yeah, you can use the ratio 1 or you use the voltage. Because I have already got the voltage, so I don't use the ratio anymore. But you can use the ratio 1 if you want. So I1, IA is equal to phi P1 over R1 equal to phi P1 is 5, phi P1 15 over with the R1 is 5. Then I get 3 amps. IB, I still use the phi P1 also, or phi B or phi P1 is equal, yeah. So phi P1 is 15 over 15. Then I get 1 ampere. And check if both of them combine in here, will they get 4? 3 plus 1 is 4. Then correct. Okay, yeah. IC is equal to, so if IC you have to use the phi C or phi P2, right? Phi P2, so phi C. So phi P2 is 4, right? So 4 divided by the 2 ohm, 2 amps. ID is phi, still use the same, phi P2, phi C, phi D, and phi E is equal, right? So phi P2 is the fifth, so the 4 again, divided by 3 equal to, yeah, 4 per 3 amps, right? And the IE is same also, 4 divided by 6 equal to 2 per 3 amps. Then try to check this all if in this junction will become a 4M. I total again, right? Then 2 per 3 plus this, 6 per 3, 2. Okay, total is 4 ohm. 4 amps. Then correct. Okay, that's all, guys. If you still have any questions, then you can ask me and we will discuss more in the meeting. I really suggest you to redo all my questions. Yeah, in the OneNote, you can upload your working. Okay, I have to suggest you to redo, because if you only see my explanation, you will not understand completely. So you can pause or screenshot the questions and try to repeat again the working in your notes. After that, If you have a problem, you stuck in some way, you can look back this video. Applications of the parallel circuits, is used in any device that we use daily, such as our car. Most of the car use the parallel system. Okay, so that's why if there is one component is not working, it will not disturb the other's component because they have their own supply. Okay, so it will be, you have learned it, if in the series, if one of the component damaged, then the current will be stopped, then the other component will be stopped as well because there's no current flow. But for the parallel, this is not a problem because every branch will supply the current. Okay, so it will not disturb if one of the components fail. So that's why in car, in computer, most of the devices, or maybe in our home, most of the devices is use the parallel circuit. Yeah, the house also, okay? You can check it at your home, right? Most of the home installation use the parallel circuit. Yeah. Yeah, this is the example. You see the light, the power plug, the socket, all is in parallel circuit. So please guys try to find the reasons. Have you ever heard that when there is a plug in here, you know the plug, power socket, there are a lot of hole here, then you are not allowed to plug a lot of instruments here. Plug, right? And you put a branch again with a lot, and there are 3. 1, 2, 3, and then here a lot. 1, 2, 3. 1, 2, 3, and after that you put again 1, 2, 3, right? After that put again, and these are not allowed. Find the reason why. Okay, this is not safe, dangerous for the electric installation in our house. So the task 1 and the task 2, 5.1 and 5.2, and the other task, please do it in the homework tab. Okay, do it, and so I know that you are studying, right? If you didn't do that, how can I know that you are watching my video and you are studying? So this is task 5.2. You can take screenshots of this. This is the task 5.3 also, and I already give you the key answer, so you can check when you do it. If you get this answer, then your answer probably correct. This is the task 5.4. There's no answer here. You have to try to do it, and there is an internal resistance in here. Sorry, this is not R1. This should be phi, and this is the internal resistance. Typo. And then try. This is the task 5.5. I already give you the answer, right? You have to try, and then you check your answer is correct or not. Okay. This is the last questions that I give. Please try it at home. Okay. Do it and upload in your homework OneNote tab. You can ask me if you have a problem. Okay. Feel free to ask. I will try my best to give the fastest response. This is the answer for the 5.6 questions. So you can compare your answer. If you get this one, probably you get the correct answer. Yeah. Okay, guys. So that's all our materials today. Then I hope that you have to keep diligent in study, because there is nothing that can disturb your study. Okay, even though we are in the far distant learning, the quality of study must be equal. I always hope that the corona or the COVID or anything else will not disturb your understanding or will not disturb your study. So even though we are having the far distance, we still study and the quality still equal with the on-site class. This is my wish, right? You understand all the topic. That's all, guys. Have a nice day and God bless you.